Hi, welcome to the screencast of PEP-435, which adds the enum type to Python standard library. Here's a little bit about me. My name is Dhananjay Nene. I blog at http://blog.dhananjaynene.com, and you can reach out to me on Twitter at @DNENE. So let's get started. PEP-435 has added the capabilities of enumerations to the Python language. It has been approved only recently, and so its features have made their way to Python 3.4. If you really wanted to do the exercises that I am doing here, you will need to install Python 3.4 from python.org, and then you should be able to take it for a test drive. In any case, hopefully this screencast should help you understand some of the capabilities this particular new set PEP really offers. So we've always needed enumerations, and the way we've often done it is something like class color, and we could perhaps say red equals 1, blue equals 2, green equals 3. So we've effectively declared constants, and while that does go to some extent in being able to make the programs easier to understand, because you can choose to use color.red instead of 1, the point is it does allow you to write code which sometimes can be very difficult to understand, or sometimes may not make sense. For example, color.blue into 2. It has no meaning per se, but because we chose to implement color.blue as a variable or an attribute of color with value 2, it made perfect sense to the interpreter, and it did the multiplication. And if I had declared let's say, here's another example, color.red into 3 equals color.green, and it says true, though obviously it's quite meaningless. Similarly, sometimes you want to actually print out these values or log them, especially in the log files, and when you do that, unfortunately, because of this particular construct, what really comes out in the log files is not red but 1. And those are some of the limitations that hopefully this new specification should help address. There's a lot more it does. I mean, for example, being able to iterate through all the colors and various other capabilities. So let's get started with implementing our enums. First of all, you would need to import the enum class, and that you would effectively write from import from enum import enum. This the latter enum here is or will be your base class for a lot of enumerations that you will set up, and here's one we will set up immediately. Let's say directions, and there are 4 major directions: north, east, south, and west. So I'll set up an enum called direction. By the way, there is a lot of noise in the background because of construction activity nearby, and there's unfortunately not much I can do about it at the moment. So in case you hear it in the final video, my apologies. Returning back to how to declare enumerations, here's a simple way to do it. This is using what is called the functional API for declaring enumerations. And what is direction? Well, it's a enum direction, not much there. And direction, incidentally, is an iterable, so I could actually iterate through its various values. And if I was to do that, I get 4 other values. Each of them actually have a name and a value associated with it. So the first one being north, which has a value 1, east, south, and west, each of them having values 2, 3, and 4 respectively. Now notice that I did not specify these values 1, 2, 3, and 4, and that was because I used the default. I used the simplest of all constructors, where I chose not to specify any values for these names that I provided, and even the names themselves are white space limited, created by splitting the string using white space based delimiters. And when you do that, implicitly the values that get associated with this particular names are sequences of integers starting with 1. Note that it does not start with 0, they start with 1. Okay, so as I said, this is an iterable, so you can iterate through it. And just to give you a little bit of an idea in terms of some of the terminology used, the direction is called the enum, and it has 4 members, north, east, south, and west, and each of those members has a name, which is north, east, south, and west, and each of those members also has a value, which in this case happen to be 1, 2, 3, and 4. Note that the values do not need to be integers. That could be any arbitrary values you choose to provide. Of course, you will need to use a slightly different mechanism of constructing the enum, and we will get to that in a moment. So direction has an attribute called underscore members, which actually allows you to access those members directly, and it's unsurprisingly it's an ordered dictionary. And if you want to you can pretty much treat it like a dictionary, so for example I could do and I get the keys are north, east, south, west, and the values, which are the 4 members. Note that the values in the members dict will give you the members, and each of those members has a name followed by a value. Okay, and I could also iterate through it saying items. So you could programmatically inspect and work with the members of any enum using its underscore members attribute. Now I showed you one way of instantiating directions. In this case, as I mentioned, the values are default values are automatically generated using sequences of integers starting from 1. Now let's say I did not want to associate these with integer values, but I wanted to use string based values for each of these members. Well, it's fairly easy to do that, and I'll just set up a different enum here, and instead of a single string I'll pass it a dict. Note that instead of a dict I could also choose to pass it a sequence of 2 value tuples, the first value in the tuple being the name and the next value being the value of the member. In this case I choose to use the dict based constructor. So here I will say north has the value n, east has the value e, south has the value s, and west has the value w. And hopefully if I got the parentheses and the braces right, it should set it up. Yes, it did. And if I iterate through that, here's I get the members, and if you note, each of the values are now strings and no longer integers. So you could choose to specify the values. And now there are some semantics that are provided on the values, but they are very, very rudimentary. For example, you could do equality checks. For example, I could say direction.north equals direction.south, and it's going to say no. If I say north, it's going to say yes. If I use on the same names across different enums, it's not going to work. So I could say direction.north equals str direction.north. Well, it's going to say that that's false. because they are of different enum classes. And I've been using one particular syntax for referencing members of an enumeration using the dot notation. There are two other ways you could choose to do that. For example, I could choose to say use the index operator passing in the name of the member, and that works. And that is the same as using the dot notation. Just to confirm that, here's the ID on. They effectively return you the same objects. There's one more way you can do it by using the value, and it's just a little bit strange. Instead of using the index or the square brace operator, you treat direction as a callable and pass in the value, and it will return you the appropriate member corresponding to that value. So in this case, it would be, because north has the value 1, I will pass in the value 1 and I get back direction dot north. So there are at least 3 different ways of being able to access a particular member from that enumeration. Now you might be tempted to think, because direction is an iterable, you should be able to access it as if it is an array, and I'm afraid that's not allowed. For example, I could say direction and pass 0 as the index, and it's not going to work. 1 as the index, it's not going to work. And the reason it's not going to work is because there is no ordering semantics between the various members, and because of that, there is no implicit ordering. When you do iterate through enum, the order that's there is based on in what orders these members were defined. These are not ordered by the values. There are no ordering semantics on members of an enum. Okay. Now there are. I explained to you one way of really instantiating or declaring enums using the functional API. There is yet another way, which probably one would use far more often, using the class-based construct. So I could, for example, say class color, and say it inherits from enum, and say red equals 1, blue equals 2, green equals 3. Okay, and that's a different way to really declare an enum. They're pretty much identical. Pretty much either way you declare them, you get the same results. Okay. Now sometimes there are some contexts where we want to have aliases, where different member names are actually aliases to the same member, and it's interesting to see how the enum class really supports it. For that, I'm going to set up or declare 2 new classes, one called time zone. Each time zone will have offset in minutes from GMT, and where the daylight savings time is used. It's a rather simplistic rudimentary class, and I'm going to declare a class called time zones, which will be an enum. So I will do that here. Okay, let's just take a look at them. So this is a time zone. It has 2 attributes, offset and daylight saving time. It has a bunch of methods on them for earlier than, equality check, this str and the repr functions. And I've declared time zones as an enum. Note that the values are provided here are instances of time zone class. And if you note carefully, for both GMT and UTC, the value is pretty much the same, in the sense that for these 2 values that I have provided here, for GMT and for UTC, the __ equals between them will return true. And what that in effect tells the enum base class is that these are aliases, that GMT and UTC are not two independent members, but they really are two different names to refer to the same member. Okay, and if you really look at it, if you iterate through time zones, you can figure out that, well, enum class had it all figured out by comparing the values and deciding which were aliases and which were not. So there you go. You only have three values here: IST, GMT, and EST. And you will not see a UTC here because enum figured it out that UTC is simply an alias to GMT. And you can check it also using equality check. For example, timezones.gmt equals timezones.ist, which happens to be India Standard Time. It says false. But instead, if I was to do UTC, it says true. Note that I've provided additional methods here on the enum class, and that's an advantage you get when you declare enumeration using the class-based syntax as opposed to using the functional API. And I have defined the necessary logic here to get a list of all the zones and figure out which are the aliased members. So we'll quickly just take a look at them. So I could say timezones.all zones, and I get IST, GMT, EST, and I could instead ask for what are the aliases, and it will say UTC is an alias to GMT. So that's one way of implementing aliases in using enums. Otherwise, pretty much everything continues to be like the earlier enum declarations we did. You could, for example, continue to access the underscore members attribute. Let me see if I can cast it into a dict. Yeah. So I have IST, EST, GMT, and UTC here. When I iterate through time zones alone, I get only 3 values, but when I go through members, I get actually 4 because here it's giving me all of them. Okay, but interestingly, for GMT it says timezones.gmt. For UTC it says timezones.gmt once again. Okay. Again, no ordering semantics are present, so something like checking for is timezone UTC less than timezones.ist. It's not going to work because all enum values are unordered and there are no ordering semantics associated with them. That should work most of the times, but there are some situations where you do want some ordering semantics, and such ordering makes sense within the context in which these enums are getting defined. And for that, one predefined class does exist that you can use, and that would be from enum. That would be called int enum. I would be able to just import it this way, and we will use it in a class or an enum called education. So I'm going to define that enumeration class thus, and as you can see from this particular context, ordering semantics do make sense. Each of these values reflect a higher level of education, and because of that we have extended this using int enum as the base class rather than enum. Okay, and this does give us ordering semantics. For example, I can say now education.primary less than education.secondary, and that it happens to be true. All right, and but the semantics here of an int enum are essentially the semantics of an integer. which does mean you could end up using these members in strange ways, in ways that don't really make sense. For example, I'm going to redefine the class color that I had specified earlier as an int enum, and say red equals 1, blue equals 2, green equals 3. And if I say education dot primary equals color dot blue, it says true, but obviously it's a completely meaningless comparison. Any reasonable way here would have been to return false. The constraint here is the fact that you essentially used ints as the values, and that ends up with this strange and awkward result. You could choose to use other value types as well here. By the way, there are other strange effects you can see in your code sometimes if you were not careful, and you could end up using these member values as integers even when such a usage does not make sense. For example, you could say list of range of education dot higher secondary. Okay, and it gives you a range. Again, this is a semantically meaningless result, and the only reason the interpreter did that was, as far as it was concerned, education.secondary was just an integer value. Okay, so sometimes it might actually make sense to use more focused value types, and you can do that. For example, the int enum is really just an alias, not an alias, but you could choose to, although it's pre-built, you could alternatively, you could have done something like this, and it would have given you pretty much identical results. So you can mix in the value type in the base class hierarchy for an enumeration. Note that the value type has to come before enum, which has to be the last base class in the list of classes you specify here. So you could do that, and you could get you could define more sophisticated enumerations which are more and more semantically closer to the exact semantics of the values that they really represent in your domain. So that's these are some of the capabilities I really wanted to talk about. There's probably a few more, but I think I've pretty much covered most of that. Hopefully it does give you an insight into how you should be able to use the enum classes. As I mentioned once earlier, you could go and read up the details here on python.org dev peps pep-0435, which has the full documentation. And if you want to play around with the enums, you will need to download and install Python 3.4, again from python.org.